The topic which we were studying this week is magnetism and electromagnetism. Okay, so we have covered almost half of the chapter. These are the learning outcomes that we have covered so far. Describe the forces between magnetic poles and between magnets and magnetic materials. Describe induced magnetism. State the differences between magnetic, non-magnetic, and magnetized materials. Describe electrical method of magnetization and demagnetization and other methods of demagnetization. Describe the plotting of magnetic field lines with a compass. State the differences between the properties of temporary magnets, example iron, and permanent magnets, that is steel. So this is what we have covered. Now we are going to cover the remaining part of the chapter, which is use of permanent magnets and the choice for material for and use of magnetic screening. Describe the use of magnetic materials in a computer disk drive. Describe the pattern of the magnetic field due to currents in straight wires and in solenoids and state the effect on the magnetic field of changing the magnitude and direction of the current. Describe applications of the magnetic effect of a current in relays, circuit breakers, and the loudspeakers. So this is what we are going to cover in this lecture.
Electromagnets are magnets that can be turned on or off by switching current on or off. As you know that around every current carrying conductor there is magnetic field, which means you can call a current carrying conductor a magnet. And this magnet, the strength of this magnet can be altered by changing the number of turns of the solenoid and current passing through it. So if you increase the number of turns of the solenoid, the strength of the electromagnet will increase. And similarly, if you increase the current passing through the solenoid, then the magnitude of strength of the magnetic field will increase. Now in this case there are two supplies connected. One is DC supply and the other one is alternating current supply. The difference between direct current and the alternating current is that the direct current has a constant magnitude and a constant direction, which in this case according to conventional current is from positive terminal of the battery to the negative terminal, which means clockwise direction. And in this case, the diagram on the right hand side, the supply is alternating. This is a symbol for the alternating current supply. Alternating current is different than the direct current in two ways, that it does not have a constant magnitude and it does not have constant direction as well. So the current passing through the alternating current supply fluctuates from clockwise to anti-clockwise, and that is the reason that in the direct current supply there is a constant magnetic field creating north and south pole on either ends. But in the alternating current source there is not a constant north and a south pole. The magnetic field will fluctuate with the fluctuations of the current supply too. So there can be two magnetic fields, direct current magnetic field and alternating current magnetic field. So alternating current magnetic field, because of the change in the magnitude of the current, the change in magnetic field also is present. So the alternating current has alternating magnetic field around it. Let's discuss some uses of electromagnets. There are three applications that are part of your syllabus for the use of electromagnets. One is loudspeaker, the other one is relay, and the third one is circuit breaker. Now starting from loudspeaker, loudspeaker has two magnets. One is a permanent magnet and the other one is a temporary magnet, which is electromagnet. And the electromagnet is actually connected with the is actually made by connecting it with the alternating current supply. And as you know that the alternating current supply has alternating magnetic field, and due to this the magnetic field of the electromagnet will change from north to south at this end. Let's say if at any instance there is a north pole at this end and there is a north pole at the end of the magnet as well, so the two poles will repel and the cone will move outward. Similarly, if there is a south pole at this end and there is a north pole at this end of the permanent magnet of the loudspeaker, then there will be an attraction and the cone will move inward. So since the supply is alternating current supply, so the change in magnetic field will cause the cone of the loudspeaker to vibrate in and out. When the poles are same, the cone will vibrate out because of repulsion, and when the poles are opposite, the cone will move inwards because of attraction. So these series of attraction and repulsion will cause the cone to vibrate, and these vibrations of the cone will produce compressions and rarefactions. When the cone moves out, it actually pushes the air, and the air particles come closer and compression is created, and this is the region where pressure is high and is called compression. Similarly, when the cone moves in, when there is opposite pole at the facing end, then there will be more space for the air molecules to move, and this space will then be called rarefaction, because this is the region where the particles are further and pressure is low. So these series of compressions and rarefactions is made by vibrating cone of the loudspeaker, and this is actually sensed by our ear as pressure differences, and we call this sound wave. Now in relay, relay is actually a safety device that is used to turn on bigger currents using smaller currents. Relay is connected in the appliances where there is large current passing, and if you turn this appliance on normally, then there is more chance of getting electric shock. So you do not turn it directly by a switch. So there are two switches in a relay. One is connected with the appliance you want to turn on, and the other switch is connected with the supply which is having a lower current. Now if you want to turn this appliance on, you cannot turn it by closing the switch directly. You have to switch on this lower current supply by using switch S. So when you close the switch S, the electromagnet of this iron becomes magnetized, and this electromagnet attracts the iron bar, and this iron bar then lets these contacts close, and this motor turns on. So when switch S is closed, the soft iron core is magnetized and it attracts the iron pivot. The contacts of this circuit are closed and the motor turns on. So if you want to turn this motor on, you do not turn it on directly by closing the contacts, because this motor is actually connected with a supply which is having larger current. So in order to prevent any harm to you, there is a smaller current supply connected, and this smaller current supply will turn this electromagnet on. This electromagnet will attract the iron bar, and then these contacts will be closed and the motor will be on. So relay is a safety device, and the safety device is used to turn on bigger currents using smaller currents. Third application is circuit breaker. The purpose of circuit breaker is to stop the current flowing in the external circuit when the current exceeds the operating current value. So it is also a safety device that protects the appliance and of course the user as well by any possible electric shock. So the purpose of circuit breaker is to stop the current flowing in the external circuit when the current exceeds the operating current value. For example, if you have an appliance that requires 8 ampere current to work normally. So the circuit breaker will stop the current flowing through the circuit if the current exceeds operating current value. Let's say the operating current value is 8 ampere and the circuit breaker is of 9 ampere. So the current as it exceeds the operating current value and becomes 9 ampere, the circuit breaker will attract the iron bar up, the spring will be compressed, the contacts will be open, and there will be no current flowing to the external circuit, which is current out. So the appliance will be protected from any harm that can be produced by increasing the current. Moving on to the last topic of this video, magnetic screening. Magnetic screening is actually the process by which we prevent devices with magnets as a part of system to interfere with stray magnetic field. Stray magnetic field means external magnetic field. Let me tell you an example. In this case, there are two poles, north pole and south pole of a magnet, and there are magnetic field lines in between the poles of the magnet. Now if you put an iron between the two poles of the magnet, the magnetic field lines will be passing through the iron, and there will be an area in between the magnetic field lines which is shielded, or you can say which is protected by the magnetic field lines, and there will be no magnetic field line passing through this area. So this area can be called shielded area or screened area. So this is how you protect the devices that have permanent magnets as part of the system, to stop interfering with the external magnetic field line, so that the magnet of the system performs its function effectively. And this is done by making the casing of the making the cases of the appliance of iron, so that the iron does not let magnetic field lines pass through, and it just concentrates the magnetic field lines around it, and there is an area which is shielded from external magnetic field lines. And this is done by making the casing of the appliance of iron.
This is also called magnetic shielding. Steel paper clip being attracted to iron, and this is a plastic clipboard. There is no disturbance by the plastic clipboard because it is non-magnetic material. So iron clip is still attracted to the magnet, right? But if you place any magnetic material between paper clip and the magnet, there will be no attraction caused. Got it? Which means all the magnetic field lines of the magnet are now passing through the steel. There is a current carrying supply, positive and the negative. The direction of conventional current is from positive to negative. And this is a paper board, and they have plotted magnetic field lines around the wire. And you can use also right hand grip rule to find out the direction of the magnetic field lines as well. Use right hand grip rule. Application. This is bar magnet plotting magnetic field lines of a plotting compass. I'll share with you all the links. It will give you. So this is a plotting compass and this is permanent magnet, right? Change the position of this plotting compass, the pointer on the plotting compass will also change. See, by this you can trace all the magnetic field lines around the permanent magnet. See, the plotting compass is telling you the direction of the magnetic field lines around the permanent magnet, and this is what is asked to write in this: plotting magnetic field lines using compass. Place the magnet on paper, north-south direction. Now place plotting compass. Okay, so it was discussed in the previous class. Now I'm going to give you some questions.
Now start solving some questions so that we get to know how these understandings apply in questions. A piece of electric equipment is sensitive to magnetic fields and is screened from them. Screened means you have to protect the electric equipment from the external magnetic field lines. So to do this, it is enclosed in a box. Which material should be used to make the box? So as I have told you, the box should be made of iron, because iron does not let magnetic field lines that are outside the electronic component interfere with the magnet of the system, so that the magnets can perform its function. So answer is B. Question number 30. What always produces a permanent bar magnet? Permanent magnet will always be of steel, and if you want to make it a permanent magnet, the current passing through it should be direct current, because direct current has constant magnitude and constant direction, so it will magnetize it. But if you will use alternating current, the alternating current will not magnetize it, it will demagnetize it. So the answer is D. Now question number 35. A relay is used in a circuit containing a bell. How can the apparatus be altered to make the sound of the bell louder? The bell is connected with the supply Q and the relay is connected with the supply P. So if you increase the number of turns in the relay, there will be no effect to the sound of the bell. So there is no use of increasing voltage of P. But if you will increase the voltage of Q, there will be more voltage of this circuit and more current passing through it. So the bell will give a louder sound. So the answer is C. Now in this question, one end of a rod picks up the north pole of a bar magnet when in position 1. So if it is picking up the bar magnet, so at this point, point P, there is a south pole because it is attracting it. The same end of the rod picks up the south pole. Now if this is picking up the south pole, then at this position there is north pole. So in this position there is north pole, and if it is not repelling by either ends of the magnet, which means the material is iron and the pole at P is actually a south pole. So the answer is B. Now in question number 26, a metal ring screens a piece of equipment from a magnetic field. These are magnetic field lines, and this is equipment which you have to protect from external magnetic field lines. So the ring should be of iron, and the iron actually carries the magnetic field lines around the equipment, and this is already discussed in magnetic screening, because if the casing is of iron, the iron will not let these magnetic field lines outside the equipment to pass through the equipment, and the magnet inside the equipment will continue working, and there will be no magnetic field lines externally interfering with the internal magnetic field of the equipment. So the casing should be of iron, and the answer is C. In this question, question 27, the diagram shows the magnetic field pattern of a current carrying solenoid, and there are 3 points K, L and M. If you increase current, the magnetic field strength will be greater, and when the current in the solenoid is increased, where there is an increase in the magnetic field strength. So if you are increasing current, the magnetic field will increase, but the increase in magnetic field will be everywhere around the solenoid, because if you are increasing current, wherever there was magnetic field present, the magnetic field will get stronger, and this will affect all the regions around the solenoid, whether it is K, L or M. So these are questions. Now, 4 plotting compasses are placed near a bar magnet. You may ignore any effects of the Earth's magnetic field. One compass appears like this. What is a possible position for this compass? So around a magnet, the magnetic field lines are from north to south. So if the magnetic field lines are from north to south, so this is the direction in which the magnetic field line should be. So at A, the magnetic field will be, or the plotting compass will be pointing towards left. Similarly, the magnetic field lines at B will be towards right. So plotting compass will point in the right direction. And in C, the magnetic field lines are from north to south. So C will be downwards and D will be towards left. So the answer is C, because they have asked in which position will the compass be pointing in this direction. So the answer is C in this case. Now, question number 33. What proves that a metal bar is a permanent magnet? As I have told you, if a substance is magnet, then it must repel. So this is option D, in which it is said it repels one end of another magnet, while in option A, B and C it is written attracts and it should conduct. So conduction is not the property of magnet only. The conduction is the property of a substance which is actually metal. So magnets are not just metals, they can be magnetized, and if they are magnetized they should repel also. Electrical apparatus is protected from magnetic fields by placing the apparatus in a box. What is the box made from? It should be of iron. So let's wrap up. In this video we have described the use of permanent magnets and electromagnets. We have explained the choice of material for and use of magnetic screening. We have described the use of magnetic materials in a computer hard disk drive. This is actually the use of magnets, that if you want the information on the computer hard disk drive tape, it has to be of permanent magnet, so that it is magnetized for that time, and you can use that data for the later purposes, so that you can access to the data after it is stored. And the coating must be of steel, so that the magnetism is retained for longer period of time. Describe the pattern of the magnetic field due to currents in a straight wires and in solenoids, and state the effect on the magnetic field of changing the magnitude and direction of the current. Describe applications of the magnetic effect of a current in relays, circuit breakers and loudspeakers. Thank you so much. Thanks for watching the video.